62% of the contiguous United States is in drought. 158 million people across 46 states. The first 3 months of this year were the driest January through March in a 131-year record. That ends this week. A 3 sigma tropical moisture surge began crossing the Gulf Coast yesterday morning, and 3 independent operational weather models are now tracking the same air mass for possible cyclogenesis between June 1st and June 10th, the same week hurricane season officially opens. The cure and the threat are arriving in the same body of moisture. Here is what the data shows. .42% of the contiguous 48 states is in drought right now. 158 million Americans are living in conditions of moderate to exceptional drought across 46 states. The first 3 months of 2026 were the driest January through March in a 131-year statistical record, beating the previous record set in 1910. The March 2026 Palmer Drought Severity Index reading was the highest March on record and the third driest single month of any season ever recorded, behind only July and August of 1934, the climatological peak of the Dust Bowl. That is where the United States has been living since the 1st of January. Yesterday morning, that began to change. A 3 sigma tropical moisture surge, the deepest pool of moisture to lift out of the Caribbean so far this year, started crossing the Gulf Coast. By the time most of you went to bed, the National Weather Service had 363 active alerts in place. 26 of them flood warnings on rivers and creeks. 2 slight risks of excessive rainfall from the Weather Prediction Center, and a 61 mile per hour measured wind gust at Port Isabel Airport in South Texas. The drought is ending. The rain has arrived. The first meaningful relief of 2026 is here, 3 days before the official open of Atlantic hurricane season. And here is the part that requires your attention. The body of moisture delivering that drought relief is the body of moisture that 3 independent operational weather models are now tracking for possible tropical cyclogenesis, a named storm, inside the same envelope in the first 10 days of June. The cure and the threat are the same air mass. The same atmospheric setup that is finally breaking the worst drought in modern American record is the setup that may produce the season's first named storm, and the season opens in 3 days. The atmospheric column over Florida and the Gulf is currently carrying tropical summer moisture in pre-summer conditions. The National Weather Service office in Miami reported that the GFS total precipitable water normalized anomaly is running approximately 3 standard deviations above seasonal means, with model precipitable water values exceeding 2 inches. A 3 sigma anomaly is the 0.3% statistical floor of a normally distributed climatology. 3 out of every 1,000 May 27ths in the modern record carry this much moisture. The Washington, D.C. sounding at the Sterling site measured 1.82 inches of precipitable water directly. That is the kind of value you expect in late July, not in the last week of May. That moisture is being lifted out of the Western Caribbean and pumped northward by 2 coupled features. To the east, the Bermuda High, the semi-permanent subtropical high pressure that anchors itself over the southwest Atlantic in late spring, is pulling warm, humid air up its western flank, across Cuba and the Gulf and into Florida and Georgia. To the west, a deep upper-level trough has been digging into the Bay of Campeche, the bowl-shaped southwestern arm of the Gulf of Mexico, providing the lifting mechanism. The combination of pulling on one side and lifting on the other is the engine carrying the moisture north. For the southeast, the rain is the cure the region has been waiting for since the 1st of January. The southeast is at 99% in drought, with 62% in extreme or exceptional categories. Arkansas at 99.5%. Mississippi at 93%. Louisiana at 77%. Georgia at 96%, with the state on drought response level 1 since the 27th of April. The rain is real, it is heavy, and it is going to land. it is also going to land hard. After 182 days of drought, the upper soil pore structure across the southeast has compacted. Hydrophobic crusts have formed on parched surfaces. The runoff coefficient on a drought-baked land surface is 2 to 3 times higher than on a normally hydrated one. The first major precipitation event into this kind of surface produces disproportionate runoff and faster rising flash floods. That is why Houston's office reported 1 to 2 inches expected with localized 5-inch pockets yesterday, and why the flash flood warnings were already verifying within hours in Dallas, Kaufman, and Rockwall counties in Texas, in Fairfield, Franklin, and Licking counties in central Ohio, and across the spine of West Virginia. The cure is arriving. It is arriving rough. The river gauge data tells you which way the precipitation is going. The Oso Creek near Corpus Christi is forecast to rise to nearly 24 feet by late morning today, fall back overnight, and rise again on Friday. That is a flash response on saturated antecedent conditions, not a slow flood. The Wolf River above Gulfport, Mississippi, is in moderate flooding with water moving onto residential property. The Pearl River along the Louisiana-Mississippi border is rising. The Jordan River near Kiln. The East Hobolachito near Caesar. The South Fork, Sabine, near Quinlan. The Saluda River at Chappells in South Carolina. The Calcasieu near White Oak Park in Louisiana. 26 flood warnings are active across the corridor right now, and that count is going to grow over the next 48 hours as the heaviest rainfall axis lifts north. Now to the part the broadcast coverage will not tell you cleanly. The same moisture body that is delivering the rain is what 3 operational weather models are watching for the season's first named storm. The European Center for Medium Range Weather Forecasts runs a 51-member operational ensemble. 51 parallel forecasts initialized with slightly different starting conditions to capture uncertainty. As of yesterday's 12 UTC cycle, approximately 5 to 8 of those 51 members are showing a closed surface low pressure system inside the Western Caribbean or Northeastern Gulf during the window from June 1st through June 5th. That puts the European read at roughly 10 to 16% probability of development, non-zero, non-trivial, at a 10-day lead. The European Center's ensemble is the most skillful operational tropical track forecasting system on the planet, with mean absolute error on its Day 5 tropical track forecasts consistently in the 150 to 200 kilometer range. When that ensemble puts 5 to 8 members on closed lows, it is a signal you take seriously. The U.S. Operational Global Ensemble Forecast System is more aggressive, showing a higher count of closed low members in the same window. The GFS has a known structural bias toward over-aggression on early-season tropical cyclogenesis. Operational forecasters adjust by roughly halving the raw probability. After that calibration, the U.S. read sits in the same 10 to 20% range as the European Center. The third system is Google DeepMind's GenCast, the artificial intelligence ensemble published in Nature in late 2024. During the 2025 Atlantic hurricane season, GenCast outperformed traditional dynamical models on tropical track forecasts by 12 to 15% against the European Center, and by 20 to 25% against the US GFS. GenCast is currently showing 3 of its 50 members converging on a closed low signature in the same June 1st through June 5th window. That is 6% probability in raw terms. The value is not in the absolute number. The value is in the independent confirmation. An architecture that is fundamentally different from the European and US dynamical models is independently picking up the same signal in the same window. 3 architectures, 3 agencies, 2 countries, 1 signal. That kind of independent convergence on a low probability event is stronger than any single ensemble's probability number. The European Center's track record on early season tropical signals matters here. In 2017, the European ensemble had Hurricane Harvey on the board roughly 9 days before formation, while the U.S. operational system was still on the fence. In 2012, it flagged Hurricane Sandy's eventual leftward turn into the New Jersey coastline, 4 days before the U.S. operational guidance fully committed to that track. The European model has earned its reputation through decade-long verification studies. When 5 to 8 of its 51 members converge on closed lows 10 days out, that signal verifies more often than not. Even at low absolute probability, the directional read is meaningful. The forecast may not be hurricane strength, may not be U.S. impacting, may not even be a named storm. But the signal that the environment supports development inside the window is real. The reason the systems are converging is not coincidence. They are picking up the same underlying environmental setup. The Madden-Julian Oscillation, the largest single source of subseasonal variability in the tropics, a 40 to 60 day eastward propagating envelope of enhanced convection that circles the equator, is forecast to be in its western hemisphere active phases through the entire June 1st through June 10th window. When the MJO is in those phases, the entire western hemisphere tropical basin experiences enhanced upper-level divergence, reduced vertical wind shear, and increased low-level convergence. Those three things are the synoptic scale prerequisites for tropical cyclogenesis. Atlantic vertical wind shear is forecast to weaken through the same window. Sea surface temperatures across the Western Caribbean and the Gulf of Mexico are running 1 to 1.5 degrees Celsius above the 1981 through 2010 climatological mean for the date. Warm enough water, weakening shear, a favorable Madden-Julian oscillation phase, an upper trough providing upper-level divergence. The conditions are stacked in favor of development during exactly the window the ensembles are flagging. The models are not making things up. The models are responding to the environment. If development occurs, the most likely outcome is a low-end tropical storm. Maximum sustained winds of 40 to 60 miles per hour, a central pressure in the high 900s to low 1000s in millibars, somewhere from the eastern Yucatan northeastward into the eastern or central Gulf, or recurving back into the western Caribbean. The probability of a major hurricane forming in this window is essentially zero. The probability of a Category 1 or 2 impacting the U.S. Gulf Coast is under 5%. The most likely outcome of successful cyclogenesis is a tropical storm that delivers beneficial rain to a parched Florida and South Georgia, runs for 2 to 3 days, makes the front of local newscasts in Tampa and Pensacola for 4 nights, and dissipates. If it forms, it will likely be called Arthur, the first name on the 2026 Atlantic name list. The real Arthur, not the fake one being marketed on social media right now. Which brings us to the noise. Since Monday, weather feeds across YouTube and TikTok have been running thumbnails of a phantom hurricane named Arthur. The thumbnails show curated satellite imagery of the moisture surge with Arthur in 50-point red type. Some versions say, developing fast. Some say, forming now. Some say, imminent. The implication is that the first named storm of the 2026 Atlantic season has effectively already formed. The National Hurricane Center disagrees. Forecaster Berg's official Atlantic Tropical Weather Outlook, issued at 8 o'clock Eastern Daylight Time yesterday, used 6 words to respond. Tropical cyclone formation is not expected during the next 7 days. Eastern Pacific Outlook, same day, forecaster Reinhardt, same. 0 invest areas. 0 tropical disturbances under active tracking. Through next Tuesday. A tropical storm is a meteorological entity with 4 specific properties: a closed surface circulation, a warm core thermal structure, organized convective banding around a low center, and an active invest area designation from the National Hurricane Center. The moisture surge moving across the Gulf right now has none of those 4 properties. It is unorganized tropical moisture being lifted by an upper trough. It is photogenic on satellite imagery. It is producing heavy rain. It is not a storm. The hype channels are showing you moisture and calling it cyclogenesis because moisture mistaken for storm generates clicks. The legitimate signal, the one that requires monitoring, is the one in the ensembles for June 1st through June 10th, inside the same moisture envelope. The hype channels are wrong twice. Once about the timing. They say today, the ensembles say next week. And once about the meaning, they treat it as a guaranteed Arthur, while the ensembles flag possible development inside a window. Calibrate accordingly when you scroll your feed for the next 2 weeks. The cost of the misrepresentation is not small. Hurricane forecasting is operationally useful precisely because the official products trade on their credibility. Emergency managers along the Gulf Coast use them to decide whether to pre-position generators. State agriculture departments use them to time early harvests. Coastal county sheriff's offices use them to update evacuation routes. Residents in low-lying areas use them to decide whether to put the boat in the yard. Real forecasting tells you what the probability of impact actually is when the next decision point is, and what the consequence is if the probability resolves the wrong way. When social media feeds burn that credibility for clicks, the cost is paid downstream by the people who need an accurate forecast when an actual storm shows up. The cure for hype is calibration to data. We do calibration here. This entire setup is unfolding on top of an equatorial Pacific that has just made one of the faster ENSO transitions in the modern record. The Oceanic Niño Index, the 3-month running average of sea surface temperature anomalies in the central equatorial Pacific that NOAA uses to classify El Niño Southern Oscillation State, was at minus 0.55 in October, November, December 2025. La Niña. It is now at plus 0.11 in February, March, April 2026. Neutral, warm side. A swing of plus 0.66 in 3 overlapping seasons. The Climate Prediction Center has the El Niño watch in effect. Onset probability through July is 82 to 98%. Persistence into the December, January, February 2026 into 2027 winter is 96%. The physical reservoir is in the subsurface, a Kelvin wave currently carrying anomalies of plus 6 to 7 degrees Celsius at 100-meter depth across the equatorial Pacific. That subsurface heat is the inertia behind the warming surface anomaly. The Pacific is going El Niño. The only open question is how fast and how strong. The relationship between El Niño and Atlantic hurricane activity is one of the cleanest large-scale teleconnections in tropical meteorology. El Niño produces enhanced upper-level westerlies across the Atlantic basin, which increases vertical wind shear, which suppresses tropical cyclone development. The suppression is strongest during the climatological peak of the Atlantic season, August, September, and October, but the suppression is not instantaneous. The early season, May, June, and the first half of July, can remain active even as the equatorial Pacific is warming, because the Atlantic basin has not yet felt the full shear response. In years where the Atlantic starts with anomalously warm sea surface temperatures of its own, the early season can be quite active even with El Niño conditions developing. That is the situation in 2026. Warm Atlantic. Favorable MJO. Weakening shear. A Pacific warming, but not yet at the threshold where suppression dominates. The window for early season tropical activity in the Western Caribbean and Gulf is wide open right now, and that is exactly the window the ensembles are flagging. 2 historical analogs are worth knowing. The first is 1933. In 1933, the Atlantic produced 20 named storms during an El Niño transition with a record warm Atlantic, the second most active Atlantic hurricane season on record before the satellite era. The first named storm of the year formed in May and reached hurricane intensity by mid-June. The activity was front-loaded. Most of the season's storms formed before late-season shear suppression dominated. The structural lesson: a basin with anomalously warm sea surface temperatures during an ENSO transition can produce extremely active early seasons because local Caribbean and Gulf conditions remain favorable, even while the larger-scale ENSO state is shifting. The cleaner recent analog is 2013. 2013 produced 14 named storms, above the long-term average, despite borderline El Niño conditions developing during the second half of the season. The activity was heavily weighted toward the early and middle months. The Caribbean and Gulf produced most of the season's tropical storms. Late-season activity in the central and eastern Atlantic was suppressed by the developing El Niño's increased shear. Neither analog perfectly matches 2026, but both bracket the question forecasters are now trying to answer. Is 2026 going to be the 1933 or 2013 scenario, front-loaded with Caribbean and Gulf activity before shear kicks in? Or is the ENSO transition going to move fast enough that the basin suppresses through the peak months? The current model spread on the August peak Oceanic Niño Index reading covers both scenarios, from plus 0.5 at the conservative end to plus 1.8 at the aggressive end. We do not get to know which one we are in until the season tells us. And here's the part that matters for the next 2 weeks. The June 1st through June 10th ensemble window is the season's first read on which scenario is operating. If a named storm forms inside that window, the front-loaded scenario is starting to materialize. If the window passes without development, that does not mean the season is suppressed, but it is consistent with the suppression case. The next 2 weeks deliver the first real-world data point on the kind of season 2026 is going to be. 3 things to track between now and June 10th. First, the National Hurricane Center's Atlantic Tropical Weather Outlook. NHC issues the outlook every 6 hours during the active season. Between now and June 1st, watch for the outlook to upgrade. If a yellow circle appears anywhere over the Western Caribbean or the Bay of Campeche or the Eastern Gulf, that is the first signal that NHC is starting to track an area of interest. A yellow circle means the agency is monitoring for possible development in 7 days, typically with low probability. An orange circle moves the timeline to 2 to 5 days at moderate probability. A red circle moves it to high probability within 48 hours. The progression is the leading edge of the actual forecast. Second, the ECMWF and Google DeepMind ensemble updates. The ensembles refresh every 12 hours. If the closed low count climbs across either system over the next several cycles, particularly if the European center's count moves from 5 to 8 up into the 10+ range, that is the operational community treating the development scenario as more likely. The opposite is also informative. If the count drops back toward 0, the forecast is fading. Third, the Madden-Julian oscillation phase diagram. The MJO is forecast to be in its Western Hemisphere active phase through the June 1st through 10th window. If the MJO progression slows or stalls in those phases, the favorable environment persists longer. If the MJO moves out of those phases faster than forecast, the cyclogenesis window narrows. 3 days from now, the season officially opens. Whatever happens in the next 10 days inside the moisture envelope we are watching becomes the first chapter of the 2026 Atlantic hurricane season. We will be tracking this in real time as the data updates. The story may be a storm. It may be 10 days of beneficial rain across a parched southeast with no cyclogenesis. Either way, the answer arrives on a calendar. And the calendar opens Sunday. For now, what we know: the drought is breaking, the moisture is real, the ensemble signal is non-trivial, and the National Hurricane Center is not predicting Arthur today, no matter what your feed is showing you. Calibrate to the data. Watch the outlooks. We will be here when the picture changes.